Far beyond the orbit of the outer planets, in the silent dark between stars, a traveler moves through space. It is not bound to our solar system. It came from elsewhere, a visitor from another star. We call it 3I/Atlas, the third interstellar object ever recorded. But what truly astonished scientists was not its speed, nor its origin, but what it carried. Water, liquid life's signature, leaking into the void far from the warmth of the sun. When we first detected it, telescopes in Hawaii noticed a faint glow that didn't match ordinary comets. Its orbit was hyperbolic, meaning it wasn't looping around our sun like the comets we know. It was simply passing through, entering our solar system on one side and exiting forever on the other. That alone made it rare. Only 2 interstellar visitors had been seen before. Oumuamua in 2017 and Borisov in 2019. Each had told us something new about the galaxy beyond, but 3I/Atlas told us something about water itself, and the possibility that it may not belong to us alone. In most comets, water begins to vaporize only when they travel close to the sun. Heat drives the process. Ice becomes gas, forming the tails we see stretching for millions of kilometers. But 3I/Atlas was different. Even while it drifted beyond Jupiter's orbit, in temperatures hundreds of degrees below freezing, it released water vapor. It was as though something inside it refused to obey the laws we understood. We ran simulations. We checked for collisions, for solar radiation, for hidden chemical reactions. Yet none could fully explain the steady stream of vapor escaping its surface. Then a pattern emerged. The data suggested the comet's ice was unusually pure, perhaps from a system where water existed in abundance. A world colder, older, and less touched by sunlight than ours. This discovery forced us to rethink how water forms and survives in the galaxy. If 3I/Atlas carried water across interstellar space, it means water can endure unimaginable distances without being destroyed by radiation. That opens a powerful idea. The seeds of water, and maybe the molecules of life, could drift from star to star, carried by comets like this one. A slow, cosmic exchange that connects entire solar systems. To understand how strange this is, imagine our own solar comets. Each begins in the Oort cloud, a shell of icy fragments left from the birth of the sun. When gravity disturbs one, it falls inward, heats up, and releases water as gas. It is a predictable dance, ruled by heat. But 3I/Atlas doesn't belong to that dance. It came from beyond. Its home star is unknown. Its chemistry is alien. And yet, in its vapor, we saw something familiar. On Earth, the spectral signature of water, the same pattern we use to detect oceans on exoplanets. That one pattern united us all in wonder. Because if water exists so far from any sun, then life might not be as rare as we once believed. It might simply travel, waiting to find warmth again. The instruments that studied 3I/Atlas, the Hubble Space Telescope, the Keck Observatory, and the ALMA Array, revealed not only water, but dust rich in carbon. These are the same elements that form organic molecules, the basic chemistry of biology. It was like finding the ingredients for life packed into a frozen interstellar delivery, drifting silently between stars. And it confirmed a theory long suspected, that comets are not just icy debris, but potential carriers of life's building blocks across the universe. But another mystery remains. Why was 3I/Atlas leaking water so far from the sun? One possibility is that its ice is not uniform. It could contain volatile compounds, like carbon monoxide or carbon dioxide, that heat more easily than water ice. When those gases escape, they may drag water molecules with them, creating a false signal of water evaporation. Another theory suggests that cosmic rays have fractured its surface, opening pockets of ice to the vacuum of space. and some scientists believe that internal chemical reactions, perhaps triggered by trapped energy from its home star, still release warmth within it, even now. Whatever the reason, it teaches us that comets can remain active even in deep space, and that the chemistry of the universe is far more complex than we imagined. 3I/Atlas may be small, barely a few kilometers wide, but what it represents is enormous. It is proof that interstellar objects can carry the story of their birthplaces within them. By studying it, we glimpse the environments of other suns without ever leaving our own system. When the comet first appeared in our instruments,